Hello everyone, my name is Manthan Vijayvargiya and I am from Team Prometheus. The problem statement that we have chosen is developing an autonomous mobile manipulator. The manipulator will be based on SLAM technology for autonomy and will be using Jetson Nano as a microcomputer. The contents of the video are as follows. We'll give you the overview of the project. We'll tell you about the hardware components, software components, future developments, applications, and we'll end up with my contributions and learning from this project. To give you our small overview about the project is divided into three main components: mobile platform development, manipulator development, and perception control. The mobile platform development includes the design, assembly, and working of the rover as a mobile platform for the manipulator. On the other hand, the manipulator development includes the design, assembly, and working of the robotic arm and its control with the end effector for object manipulation. Lastly, perception and control include the development of a vision system, SLAM-based edge computing, and ROS-based control for autonomous navigation and manipulation. Our objectives in this project is to develop an all-weather skid steering rover with durable and robust six-wheel drive platform and improved suspensions. We also aim to develop a robotic arm with 6 degrees of freedom, capable of lifting objects and dropping them accurately with multi-purpose end effector, which also includes a drill. And lastly, we would like to incorporate a vision system that enables objects identification, navigation, mapping of surroundings, and computer vision to provide the robot with autonomy and mobility. To achieve these objectives, we will be using the following hardware components. First, we'll be using the Spixhawk, which is a hardware platform for autonomous system running PX firmware with the ability to run Autopilot software for additional features. We would also use a motor driver, Sabertooth 2X32, for driving the rover's motor, a six-wheel drive chassis for providing stability and mobility on tough terrain, GPS module M8N used for accurate location and positioning data for the rover, power module APM power module for managing and distributing power to rover components, telemetry 3DR, a wireless radio module for real-time data transmission between the rover and ground control station for monitoring and seeking the commands. For the robotic arm, we use a 6 degrees of freedom robotic arm kit, which consists of all the necessary development equipments and instructions to build a robotic arm with 6 degrees of freedom, which means that the arm can move along 6 different axes or directions. We are also using servo driver PCA9685 16-channel servo driver used to control the servo motors of the robotic arm. The servo motors that we are using are MG995, which are high performance, high torque and accuracy, which makes it suitable for driving the joints of the robotic arm. We will be using Jetson Nano as our microcomputer. It is a small but powerful computer designed specifically for running deep learning models and other AI-based applications. This will be very useful for our vision system and also for a manipulator. It will run SLAM-based autonomous algorithms, which will be used in this system. Coming to the software side. On the software side, we used Mission Planner, a ground control station software for configuring and monitoring Autopilot. Autopilot Systems is an open source software suite used to control unmanned vehicles. Jetson Nano Jetpack, a software development kit used to develop AI applications on Jetson Nano. ROS Melodic, a robotic middleware used for robotic applications. MAV-ROS, a MAV link to ROS communication node for controlling unmanned vehicles, and etc. Future developments, we are planning to develop a perception control system using LiDAR camera to implement SLAM. We also plan to build a scaled version of this rover. Lastly, there are several applications to the rover as seen here. It could be used for planet exploration, extracting minerals, and creating a sufficient environment on other planets. Coming to my contributions and my learnings from this project. My contributions are more on the hardware side and the assembly of components. I I identified and integrated necessary components to improve the design. I got the knowledge of rover control and manipulation. I understood the software components through this project. My learnings. I have gained experience in assembling hardware components for the mobile manipulator, learned to identify and integrate necessary components for the project, developed understanding of how to control the rover and manipulator using software tools such as ROS and MavaROS. I also developed skills in project management, teamwork, and communication. Thank you.